All right, ladies and gentlemen, today we are talking about polygons. Polygons, it means many gons. That doesn't make sense. It means many sides is really what it means. So polygons, many sides. The first skill we're going to really talk about is to talk about congruency statements. Okay, and I'm going to tell you, I'm going to exaggerate this a little bit, but this is a really powerful statement. It's a really, really powerful statement. Okay, because if I write triangle ABC is congruent to something else, it has to be in a very specific order what I write. Okay, so I'm not going to write the second part until I've actually analyzed the rest of this stuff for a little bit. But we're going to come back to this. We're going to write triangle ABC, this little triangle, is congruent to something else. Okay, now something that I was looking at, I did grade your test last night, and there were a couple of things. People were kind of like missing a little bit of notation. They kind of would accidentally put angle signs where they weren't supposed to, or wouldn't put an angle sign where they were supposed to. These things, I know it's kind of weird. Geometry is really, really, really detail oriented. Okay, so like if there's parallel lines, you got to draw those little arrows on there. If it's a right angle, you have to put the right angle arc. And I think there'll be some time in class today for us to actually go over our test and look at them and everything else. I'll also pass out kind of what your current grade is if I can get everything done in time. Okay, so congruency statement, we're going to do 3 of these. Obviously, that's the front side of the page is what we're looking at. Okay, so if we talk about the sides and the angles, in order for two shapes, whether triangles and triangles or rectangles and rectangles, in order for two shapes to be congruent, all their sides need to be congruent, and all their angles need to be congruent as well. Okay, the corresponding sides and the corresponding angles. Okay, so if I look at a side, if I just talk about side AB, does everybody see that up there? Side AB? Yeah, that's this side right here. Okay, so if you look at it, it's between these two angle arcs right here, and it's between the 90-degree angle arc. So what side down here is between two angle arcs and a right? Yeah, it's GH right here, and you can kind of name it in either order. It can either be GH or HG. Either way works. And because they're sides, what do I need to put on top? Because they're segments. You need to do just this little thing. Do I put arrows on it?
No.
No, because it basically stops at G and H or A and B. Okay? Is that cool? So that just means, hey, that's basically the side AB and side GH. You could say segment if you wanted, but since they are technically side of a triangle, we're fine. Okay? Another side, let's just pick BC. Generally speaking, you always pick one in sort of alphabetical order. So this is what I do. I just pick up AB, BC, and then what's the last one? Well, how about CA? Okay? So alphabetical order, I just do it so it's sort of systematic. And then I just try to find the associating one, the corresponding one over here. So side BC, let me see if I can write this. I'll just do a little squiggly by it. It's between the one angle arc and the right angle. Which one's between the right angle arc and the other one? FH. So we'll write. Yeah, could it be HF or FH? Is there a difference? No. So you got to kind of pick how that's going to go. I'll do FH, but it doesn't really matter which way. Make sure that line is above it, though. You need to make sure that segment line, God bless you, is above it. Okay? And CA is going to be the hypotenuse, and it goes from the one angle arc to the two angle arcs. So let's do it in the same order. So in that case, it'd be FG, wouldn't it? FG. FG, like so. Okay? Thanks for putting that away, Sarah. I appreciate it. Okay, angles are a little bit easier because you can name them specifically. And maybe you guys aren't good at naming angles. We're going to name these with a 3-letter symbols. I just want to let you know. I could name this as angle A. But probably the best way for me to name this is to start at one letter like B, go through A, and then go to C. So this is angle BAC. Angle BAC. BAC. That's basically talking about angle A. So everyone knows it starts at B, goes through A, goes over to C. Okay? It's the one with two angle arcs. So which one down here is two angle arcs? And how do I talk about it with 3 letters? Okay? H, G, F. If someone said F, G, H, would that work too? Okay? So F, G, H. Well, let's do it this way. Let me do it the other way. Sorry. Let me do it this way. Just so I can be consistent with this. So that B was at the 90-degree angle. Let me just start at H, go to G, go to F. So HGF. You'll see why in a little bit. Okay? But basically, angle A is this first one. Okay? How would I describe, say this right angle? How do I describe the right angle? You need 3 letters to do it. So it starts at A, goes to B, goes to C. Angle ABC. Make sure you put your angle in front. Whenever we talk about angles, you need to make sure that there's some sort of symbol. Angle ABC. Okay? A has 2. We go to the right angle, and then we go to 1. So 2, right angle, 1 has to be GHF. Does that make sense? GHF. Am I going too fast? This is making sense. What's the last angle then?
Yes.
Okay, so here's what I'm looking at. This is kind of tough for some people because there's like so many combinations. Look at the middle letter. Here's A, here's B. I'm going to need C to be in the middle. The middle letter is basically the vertex. It's basically where the angle's at. So you can either say ACB or BCA. So we basically need to do the one with one angle arc. So I would say, oh, BCA, we can do that. BCA, okay. BCA, so B has the right angle, and I'm going to the 1 and then 2, so right, 1, 2. So I'll do right, 1, 2, I'll hit H, F, G, it's okay? H, F, G. Okay, is everybody okay with this? There's each one of the 3 sides of this triangle correspond with 3 lengths right here. And let me do this as well. I want to show you guys some markings on it. Was there something I messed up on? GFH is the exact same thing as HFG. Yes, they're the same thing. Okay, I just want to show you these markings in case you haven't seen these markings. When we say side AB is congruent to side GH, side AB, we're going to put one little tick mark right there. I call them tick marks. I don't know if that's what they really are. And then wherever GH is at, I'm going to put one tick mark there. Okay? So if it's 1 and 1, it means those 2 are exactly the same length. If I have BC, well, let me put 2 little marks there. Where am I going to put 2 marks over here? FH. So here's F, here's H. Boom, like so. And if I really wanted, I could put 3 down here and 3 right here. Okay? That's a good way to mark it. So we mark the sides with little tick marks, and we mark angles with either 1 arc or like 2 arcs, like over here, G or A. Is that okay? I just want to make sure you guys are familiar with this as well. All right. Now we're down here at this congruency statement, and as I told you, it means a lot. Okay. When you write this statement that's right here, it basically means all of this. All of this gets summarized with this little statement here at the bottom. You can actually, we'll do this later on, I think. I'll actually write this statement, and you'll tell me all this different information. You don't even need the pictures. You can just do it straight from this. Okay? So let's do it this way. Angle A is associated with what angle over here? Angle A and angle G, right? Okay. So the way that I'm going to write this is I'm going to write A and G are related. So we'll write if A is first, G has to be first. Okay. If B is in the middle, what needs to be in the middle? H needs to be in the middle. And finally, if C is in the middle here, then F has to be in the middle. Or I'm sorry, not the middle. Yeah. Okay. So this whole statement, yeah, that's where the round. That was good. That was that's right. I don't know why we're clapping, but it seems perfect, right? Yeah, I guess. This congruency statement, it's huge. All of this statement means all this stuff up above, and from that you can probably draw these pictures sort of all right. Okay? Can we zoom through a second one of these? I don't really want to do the third one. It'll turn out to be about the same anyway, but okay? So here's what they're doing. They're taking this guy, and they're probably like turning on its side a little bit. So we're going to have to write this really fast. The sides, I'm just going to do them alphabetically. So side AB, side BC, side DC, and then let me just do DA. Okay? All of them need to have a little side, the line segment thing above it, because they are sides. Let me just mark it this way, it's going to be kind of weird. AB, let's see what we can do here. KL. Okay. Well, yeah, we can start. Let's start at. Let's do KL. Let's just do that. We can do that. So we'll say KL. It's kind of weird with a rectangle because we could have picked JM, and we're just going to be consistent with this. Okay. And we'll say BC, and so if this is BC, we'll say I don't know NL. We'll just go around it like this. NL. And then if we say CD, that's going to be this one here. I'm going to put 3 right here. And so we'll say JM, like we're jamming. Yes? And I'm not, yeah.
Wait, you know how you did the other one alphabetically?
Yes.
Wouldn't that one be?
This part's alphabetically. This part we have to line up with the pictures. Because they purposely did it so it wasn't alphabetically so that you'd ask that question. Okay? So then DA, this part right here, we're just going to associate with JK. And honestly, we're just joking around here. We don't know. I don't know. Yeah, just kidding. I usually say just joking. Just perfect well. I don't know if they do this as Roman numerals. If they do like Roman numeral 1, 2, 3, and 4. So if you put IB on there, or if you put like just 4 tick marks. I have no idea what the 4 symbol is. You don't really see it a whole lot. So I'm just gonna leave it blank like that. I guess I don't really know what to do there. Okay. Now here's the weird part. All these angles are congruent, so this is really strange. So I'm just going to start off with, I'm just going to go around, like I'm going to do this angle, so B, and I'll do this angle, I'll do C, and I'll do this angle B, and I'll do A. So I'm just going to say angle ABC, angle BCD, angle CBA, and an angle, let's see what I have left, DAB. Dab. Angle DAB. And that's, yes, sir.
On the quiz or test or whatever we're going to get this on, would it be okay if we just named like angle A or angle B instead of ABC?
I want you to get used to the 3. Technically, that is correct to do just one letter, provided there's not multiples of that one. That's I haven't gone into that. We'll go into that at some point as well. We will not take a quiz on this stuff tomorrow. Okay. Okay. So let's see. Angle B. This is basically angle B is what he's saying. So angle B, what's that? Which one is that associated with? Is it K or is it L? Okay, angle L. So we'll say this is angle KLM. Okay, this is really hard to do. I don't know why. Let's see, BCD. Be sort of a LMJ. Angle LMJ. I do not like writing angles next to L's because mine look really similar. It looks weird. Oh, by the way, I didn't say this. All these letters should be capital letters when you're doing this. If you haven't done that, just keep that in mind. They should all be capital letters. Lowercase letters kind of mean something different in math. Why don't you guys try the last 2? Just try filling these last 2. Try sorting out what's going on here. Switch, turn this way. We're talking about. You're trying the last 2. And sometimes it takes you sort of like mentally having to spin the picture in order to do that.
Wait, so are they supposed to be the answer that you got? Just got?
They should be. What'd you have? Like, what'd you have for this one right here?
December 5. Not what you had.
What'd you have?
I did it wrong. I was at school already.
Okay. Okay. Okay, congruency statement. This is weird because you could have kind of turned. Here's what I'm picturing here. When I'm looking at this shape, what I did is I said basically, if I take this and I turn it 90 degrees, it'll be the same orientation as this one below it. So basically, A would be right where K is at, B is right where J is at, C is right where M is at, and G is right where J is at. That's what I'm sort of picturing. And if you want, you can actually probably draw it that way, if that makes things easier for you. That we turned it, so that's A, B, C, and D. And maybe that helps you a little bit. Otherwise, a lot of people will start, the more they see geometry stuff, they'll start actually doing that in their head. Generally speaking, they used to teach geometry different years and years ago, where that's what would happen. If people would just be able to naturally sort of do that, but they don't really teach it the same way, like in elementary school and middle school anymore. So, okay, now here's the thing. You know how we had the triangle symbol for triangles? There's not really a symbol. Sometimes people draw it, but sometimes they don't. For like squares or rectangles or polygons or things like that. So we don't write it, we just write the letters. So if I just write A, B, C, D, people know that if there's 4 of them, well, 4, the only thing it can be is some sort of quadrilateral, some sort of 4-sided figure. Then I have to write this thing in a very specific order. So what angle is associated with A? Okay. Which angle is associated with B? And then M and J. Okay. So that has to be in a specific order, and they're all capital letters. Is that all right? Do we have to do a third one of these? Okay, we can skip over that. No one's gonna tell anybody? Okay, I know, this is, I'm only, I know.
Actually, I don't mind either.
I know.
I'm so tired of this.
I know.
I'm exhausted.
In this day,
Polygon is a closed figure made by connecting segments. The closed figure made by connecting segments. Closed figure made by connecting segments. Maybe a little bit more of the definition. I'll sort of add this on here. There's no curves. Okay, so they're all straight lines. Additionally, there's no, I'm going to call it a crossover. There's no crossing lines. There's no crossover. Basically, if you're drawing a shape, like the sides don't cross each other. So, like if we had a shape that looks like this, that's not one polygon. It's either 2 triangles that are like kissing each other in the middle, or it's not a polygon. Okay, you can't just take it and sort of twist it.
It's like a
Look at
right
that
side
one
up
left.
tie.
Or a sideways motion on the left.
That's
so
his
it's a
name.
sketch.
Okay, so the sketch. Let's draw it like, here's a polygon. We're going to see also different polygons, but there it is.
That's cool.
Was that supposed to go in notation?
It would be like a sketch. The definition's really big.
Um,
And I'm not going to name it right now because I'm not putting letters with it yet. Okay? Open. An open one, so something that's not, let me draw maybe a couple that aren't. So these are going to be not polygons. What if we had a circle? Is that a polygon?
Mm-hmm.
No, because there's curves. Okay? What if I had this? Is that a polygon?
No.
No, so it's open, right? Okay, it's not connected. And I drew the bow tie as well, right? Okay? It can't have that crossover either. Okay? So really the big 3 things, it's got to be closed, there can't be any curves, and there can't be any crossover. There's 3 C's for it. Closed, no curves, no crossover. Feels like a better definition of this. Closed figure, there are no curves, and there's no crossover. And those are 3 counter examples of things that are not polygons. Okay? Okay. Side of the polygon is just a line segment. It's where the segments meet. Okay. So for instance, if we were going to, let me draw something that looks. Is that a polygon?
Yeah.
Yeah, it's closed. There's no curves. Hopefully you can tell that. And if I was to label this, I don't know, you can label the whole thing, but that was A and B. Then guess what? That's going to be the side. Great sketch, huh? And the notation there is just hey, side A, B. Is usually what I say there. Does that make sense? I'm not trying to make this too tough. It's pretty straightforward, I would think. Oh, and the red as, say, side A, B. That's how you pronounce it. Side A, B. Okay, the vertex. Well, that's basically where they come together. So it's endpoints. I'm going to abbreviate endpoints. Endpoints where segments meet. So for instance, B, and you might say something like, you would pronounce it vertex B, and you pronounce it the same way as well, vertex B. Okay. So vertex is where they come together. Vertex is also basically the angle that we were talking about. Okay, and we would say angle ABC, where those two come together, is angle B. B is actually the vertex. It's the corner, if you will. Okay, you want to write that? The corner. Okay, that's like a middle school term for vertex. Vertex is a high school and college term for the corner. Okay, diagonal. Holy cow! This is a segment that connects. Wow, connects. Sometimes when I'm recording this, like it skips some of my handwriting recognition. I really don't have this bad of handwriting. It connects two, I'm going to put a weird word up here, non-consecutive, what in the world? This is ridiculous. Non-consecutive sides. Non-consecutive, not sides, vertices. Let me say that again. There are segments. It's a segment. Wow, this is awesome.
Does that say vertex?
Segment
Vertices.
that connects two non-consecutive vertices. This is a plural for vertex. It's like if you have vertex is one, vertices is two. I know, it's kind of weird.
Mm-hmm.
So, for instance, if we had this polygon, okay, each one of these right here, each one of these corners right here is a vertex, okay? So I can draw from here, I can only draw one diagonal, right? Because the idea here is that if I start here, then I go consecutively. Consecutive just means in order. So like this is my first one. B is also, it would be the next one, and D would be the one right before it. So it has to be not next to. Okay, non-adjacent would be another way to put this. Okay? If I had a, let me draw one of these guys. What's this thing called?
No, a pentagon.
Hexagon.
Oh boy.
Hexagon.
We're definitely going to be. Sorry, there's 6 sides, so it's a hexagon.
You say it.
So if we were to draw from here, okay, we couldn't go to this one right here. We can't go to this one right here, but we can go to here. We can actually go to here, and we can actually go over to here. You can't do the two that are right next to it, but you can do all the others. Okay, so those are the non-consecutive sides. I don't think there's really a way to, well, I guess I drew them, but you can't, there's not really notation for it. Are these okay? These 4. Does everybody have this pretty much down? Everybody's good here? Wait, okay, as soon as I change it, someone else is saying wait. Sierra!
I said wait.
Okay, sounds good. Okay, concave and convex. What does concave mean?
Concave.
Hey.
Concave. Okay. You always got to look for the words because there's usually some sort of context clue here. It has a weird definition. At least one diagonal. Let me make sure I read this correctly. On the outside. Okay. So is that if I'm drawing this? Is that a polygon? Yeah, that's connected. Okay, that's connected.
It's like a square Pac-Man.
It's kind of like a square Pac-Man. It's actually a pentagon because there's 5 sides to it. If I was drawing diagonals from right here, okay, I could draw a diagonal that would go over here. Well, look at this one right here. That diagonal goes on the outside. So because there's sort of like a because it kind of goes in, like it collapses in, like a cave where you could like walk into the cave. Okay, you could walk into Pac-Man's mouth there. Because of that, it's called concave. Okay, concave because you could walk in it. Convex is just the opposite. It just is like no diagonal on outside. Okay, all of them are on the inside. So like pretty much any shape that you normally think of. If you drew all these diagonals again, I'll draw them from over here. All the diagonals are on the inside. If I would have scribbled outside that. Okay, so you have convex or concave. Think of a satellite dish. Okay, the inside of it, right? Okay, that's concave. Okay, it's concave. Okay, think of a big bubble. Okay, like you're blowing a bubble gum. Okay, a bubble, if it was a polygon, it's not really a polygon, but it's convex because it's kind of coming out. But a satellite dish that you can sort of like store stuff in. This is the way my teacher told me. If you can store stuff in it, then it's concave. Like a bear. There could be a little bear in there. Hanging out. A bear. They hibernate. Hibernating in the cave. A bear could be hibernating in the satellite, I guess.
You claim you
Okay, we're almost there.
Okay.
Congruent polygons.
Pressure rock.
Congruent, what does congruent mean?
Same.
Same. Check this out. Polygons. This is so easy. Polygons. Having the same size, that's one thing, and shape. Okay, that's the easy way of putting it. Same size and shape. Okay? And as we talked about before, let me just pick easy ones. I'm going to draw two triangles that look like this. Okay, I'm just going to label them A, B, C. And I'm going to pick three other crazy letters here. How about W? Let's do Q. Let's do, oh, P is so underused. Okay? And so what we would do, our notation, I know that I'm kind of scribbling outside of the notation, but we would write, basically, we'd write triangle ABC. Okay? And we'll say that it would be congruent to triangle, let's just say W, Q, and P. Okay? There'd probably be some little notations on here, like some of that stuff, some of this stuff. There'd probably be like a little angle thing somewhere in here. You get the idea. We already did this, right? That was the first page, right? So we're okay with congruent polygons. We're okay with
I
congruent.
like your P
You like the P?
over there.
Pretty nice, isn't it? Pretty spectacular. Okay, perimeter. We're gonna put a little plus sign there. It's the sum meaning plus, we're adding them together, of the lengths of the sides. Does that make sense? You guys have been doing perimeter forever, right?
Since third grade.
Sums of the lengths of the side. So for instance, if I had some drawing, whatever, it looks like this. This side's 3, this side's 2, so 3, this is 2. Well, what do? I say 3 plus 2 plus 3 plus 2. I add them all up, that's what the sum means. And that'll be good. About 10. I don't know where you guys are going to fit this, but I fit it right there.
1, 2, 3. I just like the pictures small.
Okay, that's a good idea. And we probably have to put some units with this. If it's not given to us, we'll just say units. If it's like feet, we'd write feet. If it's yards, whatever it is. Okay? Are we good? Can you handle this? Okay, we're almost there. Okay, check this word out. Everyone knows this word, equilateral. Everyone say equilateral.
Equilateral.
Say it again, because that was so awesome. Equilateral.
Equilateral.
Okay, what does equilateral mean? Yeah, it basically means all sides, maybe all side lengths are congruent. All side lengths are congruent. Equi means equal. Lateral means side, so equal sides makes pretty good sense to me. I'm really not good at drawing a lot of these pictures of figures, but I'm gonna I'm really good at drawing a hexagon, or I think I'm pretty good at it. So we'll just do that. I think I'm pretty good at it. Like some people, not good at it. I have the little tick marks on here. What does that mean?
They're all equal.
That means they're all equal length.
Darn.
Oh, so you're making fun of mine that's like a foot tall, and you're drawing yours that's like an inch tall? It's a lot easier to draw things that are an inch tall than a foot tall. Especially when I'm using these giant crayons, so whatever. Back off. Okay? So we talked about equilateral, right? This word is pronounced weird, okay? The reason it's pronounced weird is because there's a UIA. Okay? A UIA. It generally speaking does not happen that you get three vowels in a row. I watch Wheel of Fortune a lot, and three vowels in a row does not happen all that often. The word beautiful is an example. Beautiful has an EAU as well. This is a UIA, so it's pronounced differently than you would think. Okay, this is generally speaking, people say equilateral for some reason. I don't know why I'd say equilateral, but it's technically equilateral. And I know it sounds really weird. This is fun to say. This is equiangular. Equiangular. Everyone say it. Yeah, isn't it a weird word? Equiangular. Okay. What do you think equi means? Equal. What do you think angular means? Yeah. So, what do you think that means? Angles are congruent. Is this easy or what? Look at that. You're going to use the sign for congruent. Okay. So if I was going to draw a triangle, and this was 60 degrees here, and 60 degrees down here, and 60 degrees over here, that'd be equiangular. Equiangular. Okay, regular polygon. It does not mean that it goes to the bathroom regularly. Okay? That's not what it means. It doesn't mean, that's what, if you talk to old people and old people are not regular, it means that they go to the bathroom like once, and they don't go to the bathroom for like another 2 or 3 days. Okay? Generally speaking, I know, generally speaking, people need to like flush their, I don't know why I'm even talking about this, but generally speaking, people need to flush their systems. You probably know what I mean. About once a day. Maybe you're a little bit different. Maybe you're once every 2 days, whatever it is. But generally speaking, after you get to a certain age, you're pretty regular, and you might even go at the exact same time every single day. That's being regular. This is not what this means at all.
So we're not regular.
Okay. Okay. This means that all sides and all angles, I'm going to say angles like that, are congruent. All sides and all angles are congruent. So, you could actually say this is both equilateral and equiangular. That's an arm. Nice. That's an instrument.
Wait, hold on. I'm confused about what you were. All sides.
All sides and all angles are congruent. All sides and all angles are congruent. Obviously, the angles aren't congruent to the sides, but think of a square. If you think of a square, aren't all the angles 90 degrees? That makes that equiangular. Okay? Because it's equal angles. They're all 90 degrees. Okay? Then think of the sides. Aren't all the sides the exact same? Whoa, my phone just went off. I need to go to the office.
That's a green slip now.
Can I write it?
Oh, girl.
Sure.
Fail. Fail.
Just kidding.
So equilateral and equiangular. Okay? So it's both, like a square. Hang on. I'm only going to do one more thing. This is what's on your quiz tomorrow. This is your quiz. I'm just going to tell you, this is basically your quiz. And honestly, you guys are probably already know the majority of this is going to be okay. Okay, the diagram, it's on that page. I just wanted to finish the page. We'll just do it this way. Is there any two-sided polygon? Do you have a two-sided polygon? No, that's like an angle, right? Like you can't have a two-sided because it'd be open, right? That doesn't make sense. Okay, so the smallest polygon you can have has 3 sides. What's it called?
Triangle.
Okay, they're all called triangles. And then you're going to draw a picture. I'm going to draw a right triangle. Look at this.
That's right.
Bam. Yeah.
That
Okay, fine, good. Okay, tough one. You guys are gonna say the wrong answer.
Quadrilateral.
Oh.
equilateral.
Square.
Triangle.
Every single four-sided,
Polygon.
every single four-sided polygon is called what?
Quadrilateral.
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 Try me three.
So I was right the first time before you said we were all gonna get it wrong.
Quadrilateral, make sure it's spelled correctly. Quadrilateral is any four-sided figure, okay? It's like this. I could say, raise your hand if you're an athlete, and that'd be football players, cheerleaders, lacrosse players, soccer players, bridge players, cross-country players, whatever you do, okay?
Bridges.
Okay?
Bridge level.
I play bridge with old people. Okay, so but then I could say, okay, specifically, let's talk about football players. Or let's talk about soccer players. Let's talk about cross-country players. Okay. So here's the deal, or soccer players. We can talk about soccer players.
It's like where you play the whole
But quadrilateral is what sort of encompasses all four-sided shapes. So I'm actually going to draw a parallelogram up here. A parallelogram. And because it's a parallelogram, I'm going to draw like little arrows on here to show those sides, the opposite sides of the parallelogram. Okay, so parallelogram. That's a type of quadrilateral. Just needs to have four sides. Draw any quadrilateral that has four sides. You drew a square. Good job.
I have a question. What is this one called?
What?
A rhombus?
That's a trapezoid.
A trapezoid?
That's a step.
Yeah, it's trapezoid. It's basically a triangle with its head cut off.
So is that a four-sided figure?
Oh,
That works?
Because there's four sides, right?
Hurry, look, I wrote a triangle at the top, so there looks like there's space in between.
What's five?
Pentagon.
Pentagon.
You know what I mean, though?
Pentagon. Penta means five. I can't think of any good examples for pentagon. You could draw like a house. House.
Yay.
House. Six. Okay. Hexagon. Very
I
good.
remember it because it has an X in it, so it's a six. Yeah.
Oh, that's a good way. So hex has an X, and six has an X. The way I remembered it is because if you guys think of 666, it's like devil and witchcraft and all sorts of crazy stuff. Like a witch casting a hex on you. Yeah. Okay, any six-sided figure. Six-sided, that's supposed to be a regular hexagon.
Nice
Whatever.
try.
Yeah, it's terrible. Okay.
No, that was actually good. Nice try on the witchcraft thing.
Yeah, okay. So, okay, we're at seven. And
Okay.
seven, depends on what book you look at, they'll give you different answers. Okay? I have seen, I think this is pretty cool, a septagon.
Ooh.
And the reason is because, well, I'll tell you later on. Like September. September actually originally used to be the 7th month.
What happened?
It used to be the 7th month. I'll tell
What
you
happened?
we're going to get to the rest of it. Sep actually means 7 in Roman. Sep means 7, so 7. But it's actually, I don't know why we've changed it, but we've changed it to a heptagon. Changing the H to, or the S to an H. I'm not going to draw 7, 8, 9, 10, 11, 12. Just know that it has that many sides. Is that okay? Okay. 8.
Octagon.
Octagon, like an octopus.
I remember it's octagon.
Octagon, you think a stop sign? I'm going to write stop sign up here. I could probably draw it, but there's really not enough room. Like a stop sign. Stop sign? Here's a red?
We have to actually draw the picture, though.
You don't have to.
Oh, I can write stop.
Okay. So, just like October used to be the 8th month, it's not the 8th month, it's now the 10th month. I'm going to tell you. Hold on. 9. Nonagon. So it used to be
November.
you get it, Scott. Number 10, decagon. Before you say anything. Wow, what is going on here? Decagon. That's a C. Decagon. D-E-C-A-G-O-N. Deca like a decathlon, like a decade, like a decimal point, like December, but December is the 12th month.
Oh, I don't know why it changed.
11. This is weird. I did not learn 11. There's actually, it gives it to like 30. This is, and then un. Un for being one. Decagon. Un decagon. So un meaning one, like uno in Spanish, or what's it in French? Alma? I did good. Okay. That sounded good. It sounded totally French. So un decagon, deca means 10, un means one. And guess what? What is 2 in Spanish? So we say dodecagon.
Is that what you just said?
Dodecagon.
How'd you know?
He's S-M-A-R-T.
No, oh yeah, thank you. I wonder why it was much changed. I really want to know.
We're talking about. Okay. So here's n. If we had like 50 sides, we call that a 50gon.
Really?
If we have 100 sides, we call it a 100gon. This is what we call it. And there's, I'm not even sure how many zeros it's going to be. This many gon. Okay, that's what we call it. And we just pronounce it. Don't say a gon. It didn't happen like ago. It's just gone. Like 50 gone. Like 100 gone. Like if we had dog sides, it'd be doggone. Doggone.
So that's what the
I
quiz
just
is
want to know
gonna
what happened
be.
to the month.
So we'll say n-gon because it's n is just the number of sides, where n is your part.
What about be gone?
Okay, so let's talk. That's basically the part that you're gonna have a quiz over. It's this green and blue stuff here. Don't worry about drawing the pictures. So you better know the names from 3 through 12. Okay, let's talk about the months really fast.
Yeah.
January's fine. February's fine. April, May. I missed March. March, April, May. Okay. Here's the part that messes up. It's June and July.
They came in, I don't know, messed up.
Actually, June's fine. July and August got added. There used to only be 10 months. Think of some Roman person whose name is close to July. Julius Caesar. He said, I want a month named after myself. So he got himself a month named after himself. Augustus Caesar as well. They were so famous, they were so conceited, they're like, I want a whole month dedicated to me because I'm the emperor. I'm basically a god.
I'm
I
wrong.
deserve it.
Yours comes after I
Why did they, when did they get active? Do you know what?
It was around 150 to 200. It's about when they got added.
BC.
What about people's birthday? How did that work?
I don't think they really